All right. So FizzBuzz is, literally, like 5 lines of code. And so, I was reading a blog entry where the people were like, oh, that's simple. Haha, look at all these people. They can't pass FizzBuzz. And then on the blog entry in the comment section, they wrote their implementation of FizzBuzz. And their code was wrong most of the time. And the most common, like, I actually went through the comments, and there was like 40 or 50 different people that submitted their own versions of FizzBuzz. And the most common mistake they made was they went from 0 to 99 instead of 1 to 100. Or they'd go from 1 to 101, something like that. They'd have an off by 1 error in there. And so it was really funny because all these people were like, haha, look at these morons, they can't do FizzBuzz. And then more than half the people that submitted their version of FizzBuzz had it wrong. And the most common mistake was an off by 1 error here. And so you have to, make FizzBuzz. And there's a for loop down below that counts from 1 to 100. So you have to make sure that you are doing that properly. And then I'm recording now, so I'll mention what I said again. Most students wrote their code first, and they wrote the tests afterwards, which runs contrary to the whole point of this lab. The whole point of this lab was to have you guys do the tests first to learn TDD, and instead you guys were just kind of like, well, I'll get it working, and then I'll make tests that match it, and it's not what you're supposed to do. So you're supposed to have 5 error cases, 5 good cases, and in this case I have 6 edge cases. Edge cases always go around the boundaries of if statements, right? So like here I've got a boundary at 1 and I've got a boundary at 100, so I'm testing at the boundary and then 1 up and 1 down on it. Because the most common mistakes that people make in their code are off by 1 errors. And so that's what you guys should be doing for the edge cases. Can you show your FizzBuzz 2? Nope. I'm recording now, so next year's class might watch it. But for FizzBuzz 2, what you do is just add the digits together, and then you also see if the digits added together are FizzBuzz, Fizz, or Buzz, just like this. So the only thing different for FizzBuzz 2 are numbers where the digits add up to 5. Because all numbers that add up to 3 actually are Fizz already, because all numbers that add up to 3 are already Fizz, because it means it's divisible by 3. So the only difference between FizzBuzz and FizzBuzz 2 are numbers where the digits add up to 5, like 41. So for 41, FizzBuzz would return 41, and FizzBuzz 2, 41 would return Buzz. That's the only difference. Okay. For all other cases, like 15 and things like that, they're going to be exactly the same. No face cam? Oh. Should be on. Window projector source. There we go. There you go. All right. So that is FizzBuzz TDD. And again, the whole point of this wasn't to challenge you guys in writing the program. It was to challenge you guys in learning how test-driven development works. And it's a good feeling to see the greens pop up, right? But if you just wrote your tests after you wrote your code, then what? The problem with that is that when you write your tests to match your code, then you're not really exercising your code. You know what I mean? Like, if you didn't consider negative numbers, like in this assignment, I spelled out directly if it's a negative number, return error. But in reality, you have to come up with those things yourself. You have to come up with, what does bad input look like? Like a job interview question. A friend of mine works at Pandora, and so his job interview question is this. He says, "I will pass you a 3x3 array." You guys know tic-tac-toe, right? Tic-tac-toe. It's going to have a 3x3 array of characters, and each spot can be blank, an X, or an O. And then you return to me, if somebody won or not, right? And so he gives them 15 minutes, or they can sketch it out, whatever, to write, something that will say, X wins, O wins, or draw, or no one wins, right? Or error. And so here's the thing. Most people who do that, they don't consider the fact that he could be passing them not a valid tic-tac-toe board. He could pass them 9 X's, right? And most people just don't even consider that. Like they just, the first time you get 3 in a row, return X wins, right? What if you return 3 X's, 3 O's, and 3 O's? right? That's not even a valid tic-tac-toe board, right? And so it should return error, right, or something like that. Or or two people won, or like it doesn't even make sense, right? But he could pass that to you, and he does pass it to you, and then he's like, why didn't you handle that? And most people's answer is like, oh, I just didn't think of it. And the reason why they don't think of it is because most computer science professors, don't hammer that into their students, that you have to think of every possibility. If you have a function that takes a 3x3 array, there is no guarantee that it's going to be a valid tic-tac-toe board. And so the first thing you should do probably is check for it. And so for a valid tic-tac-toe board, the number of X's and the number of O's have to either match, or there could be one more X than an O, right? And so if there's 5 X's and 3 O's, that's error, right? And so you have to come up with tests that exercise your code in different ways. You have to come up with a test for that you pass in wildly wrong information, right? And that's why I broke these out into good tests, bad tests, and edge case tests. And some people thought bad test means the test was bad. No. You're passing in bad input. You're passing in bad input to your function, like -100 for FizzBuzz, right? Or you pass in 5 O's and no X's for tic-tac-toe, right? So you have to get into that habit of mind of having bad input passed in and your code handling it. So one of the things that I hate is having my code crash, right? Or behave badly, or fall into an infinite loop, or to not handle error cases correctly. And a lot of it's actually a philosophical thing, right? Like, a lot of professors will say, well, if somebody's passing in 5 O's and no X's, then it's their fault, right? Like, that garbage in, garbage out. It's up to them to verify the input's good. You have a precondition that your precondition is that it's a valid tic-tac-toe board. And I'm like, yeah. No, not in the real world, dude. In the real world, you will be getting bad input, and maybe you have a part where you vet the user's input and you detect errors there, and then after you vetted it and made sure that this thing is a valid board, then you pass it into your thing that has a precondition that it is a valid tic-tac-toe board. But that's just moving the responsibility for error checking to a different place, right? And a lot of computer science professors just don't teach you to deal with that input, and that's why people get hacked left and right. I don't trust anything that comes in input, right? I don't trust anything. If it comes from myself, I still don't trust it. Like every time I create a new class, like every time I come in here, sudo create a new class, like this is a script only I can run, right? And I still ask myself, like, have you remembered to keep the leading zeros in students' usernames? So I forget that all the time. And I'm like, oh, no. And then it quits. And when I then create class, and if you look at how much error checking I do on this is only run by me. The input is made by me. The script is made by me. I'm the only person on the server that can run it. And even still, you didn't run it as root, quit. You didn't pass in the right number of parameters. Print out how many parameters it needs, quit. Test for sending the file name. I remove everything that's not a digit or a lowercase or an underscore. If it's invalid, quit. If the class name doesn't exist, quit. If they didn't type in yes, quit. I go crazy hard onto error checking, even something that's me run for myself. I do not even trust myself. And now take that paranoia and apply it to people on the internet that I trust even less than myself. Like, no. Like, anytime I have anything that takes internet input, like a web server or something like that any input gets sanitized, like, to the high heavens, right? I do not trust anything that people give me. So, yeah, and then here it's cutting out all semicolons, all spaces, cutting out any username in there that doesn't have a digit or a lowercase and underscore in it. I don't trust my file names. I don't trust the students in the file. I don't trust anything. Everything gets vetted to make sure that the length of the student name has to be at least 3. Yeah, like the number of error checks that I put, even in something that I don't even share with the rest of the world, that requires root privileges to run. Yeah, okay. So if you have a function that takes in a wind speed, you should better have it handled in case the speed's negative. Yeah, and so yeah, like the Boeing 737, right? The 737 Max. The reason why the 737 Maxes were crashing was because there are these things called pitot tubes on the sides of the front of an airplane. It's a little tube, and air comes into it, and it uses the air flowing through it to detect how fast the plane is moving. And these pitot tubes can ice over because you're taking off through clouds and it's freezing and stuff like that. So ice can get in them, and that ruins the airspeed measurement. Now every plane has two of these things, but Boeing decided to squeeze the airlines for extra money. And so even though all the planes have two pitot tubes, if they wanted the software to read data from two pitot tubes and to report an error message when the two of them have disagreements in the airspeed, they charged $100,000. It was like DLC, except if you don't buy the DLC, then your planes crash and hundreds of people die. And that's what happened. So Lion Air and Ethiopian Airlines didn't buy the $100,000 package to enable the lines of code that were already in there and to enable the hardware that was already on the plane. So what happened is these planes would take off, that they would get ice in the pitot tubes, which happens all the time, like 1 out of 1,000 or 10,000 or 100,000 flights. I don't remember. It's not every flight, but it's often enough that there's no way that it should have ever resulted in a crash. I took fault-tolerant systems in grad school, and my fault-tolerant brain, was screaming in outrage when I read what Boeing did, because there should never be a single point of failure in a plane that caused it to crash, and that's why you have two of these things, right? And the fact that they're like, no, we're just going to disable the redundancy, and charge for it. I was just like, whoa, whoa. Yeah, but like with more cursing. So, yeah, and so what would happen is the thing would ice over, the airspeed indicators would indicate they're not flying fast enough, and the plane would take over from the MCAS system, would take over from the pilots and nose the plane down to get more speed so that the plane wouldn't stall. And then the pilots would try to fight back control against the autopilot system, and the autopilot was basically overriding the pilots, which is also another horrible thing to deal with. And the pilots weren't notified how the system worked. They were basically told this plane flies just like any other 737. They went through a cursory training program, and the fact that the MCAS system could literally seize control of the plane and drive it into the ground and crash it was not in the instruction manuals anywhere. And how to handle that was not in the instruction manuals anywhere. And so the Lion Air flight that crashed the day before, the same thing happened to it, but there was a pilot sitting in the jump seat, and the plane started nosing down. They were trying to pull it back up and go up, and then it would try and fling itself into the ground again. The guy in the jump seat was like, hey, I read about something on the Boeing forums about this happening. Try manually trimming the plane. And there's this wheel on a 737 that allows you to manually screw the elevators on the back tail of the plane up to keep the nose pointed up. You can manually trim it, but you have to spin this giant wheel thing, and it's a slow process. And you're doing this while the plane's literally trying to fling itself into the ground. And if that guy hadn't been there, the plane would have crashed the day before. But he wasn't on the plane the next day, and the pilots who had gone through the Boeing approved training process, which was a tablet, thing, you sit there and you read about it for 10 hours. Yeah, so many different things went wrong, and all of them were bad. It wasn't like it was a rare failure. It was literally they didn't train the pilots properly. They charged for a safety feature that should have been on by default. And even then, the autopilot should not override the pilots. If the pilots should be able to take control back from the plane if it's trying to fling itself into the ground. And I was just utterly outraged by Boeing, because the Boeing of the 1980s would not have done that. The Boeing of the 1980s and the 1990s had a culture of never ever let a plane crash. You know what I mean? The plane should be able to get shot to high hell, and you should be losing hydraulics, and the plane should still fly as much as possible. That's the whole point of fault tolerant systems, is that you can have a bird hit your wing and knock off an aileron or something, and then the plane, the system will handle it, right, as best as it can. And if you lose hydraulics, then there's cranks where you can manually crank, the elevators and ailerons into place. You don't even have one bundle of wires running the length of the plane, because if that gets severed, like let's say you get hit by a bird and there's a piece of shrapnel and it cuts all those wires, then you lose the plane. And so there's multiple routes for the wires, and like the amount of thought they put into having planes not crash made me very comfortable flying in planes, because like I knew how much engineering went into these things. And then I'm reading about the new Boeing, where the new management took over at Boeing, where they had a culture of like the new managers at Boeing came from the business side of things, and about cost saving measures, and about marketing guys and things like that. And so the 737 Max is my camera cutting out? Weird. The 737 Max was designed to get more fuel efficiency, but it kind of ruined the entire airframe of the plane, because the engines were too big and they couldn't go down, so they had to go forward, and so that affected the front-back balance of the plane, which is why they had to put in the MCAS system to keep it from nosing up or nosing down, because of the altered center of gravity of the engines. And the whole thing was designed as a cost-saving measure, so you didn't have to retrain pilots, right? It's still a 737, so if you're qualified on the 737, you can qualify on the 737 MAX, and the software patch was designed to hide the fact that it was actually a substantially different plane. And then there were bugs in the MCAS system, also due to cost-cutting measures, or trying to squeeze an extra $100,000 per plane out of airlines, and the whole thing was a giant CF, right? So, yeah, and so basically, it was the corporate culture, it was the management at Boeing who's really at fault here, and also the engineers who wrote it. I would not trust, anything to be a single point of failure. In this case, the AI plane, taking over. Like, do you trust that's going to work right? No, you need some override where you can just cut that thing off, and steer the plane, yourself. And so, and the MCAS system was so integral to keeping the flight level that they didn't really allow you to do it without losing all control. And so, yeah, it just from top to bottom, like everything about that was bad. And so now the 737 is declared airworthy again. They're going to start flying again. And it's just like, I'm glad Boeing lost billions of dollars on this, but I'm still furious at them. Because that is the philosophy you need to get into when you're making things that are going to be in the real world that could cause people to die. Don't trust anything. Write defensive code, right? And these professors that are like, well, it's somebody else's responsibility. It's the single responsibility principle that only one person should be responsible for error checking. And I'm just like, no. I'm not going to have my planes fall out of the sky. I'm not going to have my bridges collapse. I'm not going to have my functions crash or seg fault ever. And that's just a philosophical thing that I have. And I understand that not everyone agrees with me on it, but that's a hill I will die on. I mean, not literally. It's kind of the opposite. Okay, so we're going to talk about lists today. So you're new. What's up?
I made Thai chicken satay right now. What time is your lunch?
My class gets out in an hour.
I also made peanut sauce.
Sounds good. Okay. Mace.
Yep,
can you pour the second coffee into here?
No.
Nope? Okay, thanks. Alright.
I need to attend to the chicken, man.
Yep, it's fine. It's so great being married. Alright. So, our next homework assignment is going to be called Superhero Mart. And so Superhero Mart is, you're going to be making a supermarket for superheroes. Okay? It's a superhero supermarket. And so basically there are 3 types of items that superheroes will buy at your Superhero Mart. There's weapons, armors, and gadgets, and there's slightly different rules for all of them. You're going to be using the list class. You're going to be using the list class from the standard template library. You cannot use vectors in this. If you use vectors in it, you will get a 0. Do not use vectors in it. There's a note to that effect in the source code, I believe. And I'll put a note on Canvas as well. Don't use vectors. Can't use vectors. You have to use the list class. Time to learn a new data structure. This is a data structures class. Time to learn a new data structure. We're on week 5, right? So there's weapons, and so let's add a weapon. So every item is a name and a price. It's very simple. You should probably make a class for that or something, right? So enter a weapon. I'm going to make a nunchuck. And the price of a nunchuck is $20. Okay? And so after I add the nunchuck, it lists all the weapons in stock. And there you can see I've got a nunchuck. Price of $20. Did you know that nunchucks are illegal in California? It's true. Back in the 80s, there were a bunch of ninja movies coming out. And like the original, like the ones I was showing you before class, the Shaw Brothers Kung Fu flicks, and Bruce Lee and American Ninja, and stuff like that. And so California legislators were paranoid that street gangs would be roaming the streets with nunchucks and assaulting innocent passerbys with their incredible martial arts and ninja-like nunchuck skills. And so California is one of 2 states in the union that still has nunchucks being illegal today. For a while, there's like 20 states that had banned nunchucks. You can still buy guns, right? But nunchucks, no siree Bob. And there is an exception if you're going to a martial arts school, but it's unclear how you can possess nunchucks if you're, at home, right? Because you're not going to martial arts school. So, yeah. So let's add another weapon. Let's add a sai, and a sai is, of course, $40. And we'll add a katana that can cut through tanks. That's $100, of course. And you can see that just the weapons are just listed in the order they were added. Okay. And if I were to purchase a weapon, weapons are just purchased in the order they're listed. A superhero walks in, says, I need a weapon. And the stock clerk says, well, the first thing here is a nunchuck. Here you go, nunchucks. Let me buy another weapon. All right, here's a sai. Let me buy another weapon. All right, here's a katana. So they get sold in the order they're stocked. Okay? And if you try purchasing another weapon when there aren't any, then it dies. Right? Bad input. So yeah, so California still has nunchucks illegal to this day, which is very California-ish. Right? But I mean, what can you say? There are no roving bands of ninjas on the mean streets of Los Angeles, so I guess it worked, right? Fresno's not overrun by a bunch of nylon jumpsuit wearing ninjas on the rooftops swinging nunchucks at people. Clearly the legislation was successful. Yeah, special case. If you try buying nunchucks, it's like, no, that's illegal. We don't do that here, right? Teenage Mutant Ninja Turtles. That's New York. New York, you can buy nunchucks in New York. Not in California, though. It's so dumb. Okay, so let's talk about armor. So armor, enter an armor. Let's get body armor, and that costs $300. And then we'll get a t-shirt. And t-shirt's $5. And armor, 100. What the heck? Let's try that again. Armor. There we go. It's because there's a space in the name. Yeah, every item has to be a single word. Okay. So let's add a T-Shatsu for $5. And then let's add a bulletproof vest, all one word, and that'll be $300. And look at this. So armor is going to be sorted alphabetically. So I added armor first, then t-shirt, then bulletproof vest. You'll see that the bulletproof vest is now in front of the t-shirt. So the rule for armor is that it must always be sorted alphabetically. And then again, when people buy things, armor is purchased, buy thing, bulletproof vest, buy an armor, t-shirt, try buying it again, bad input. Okay, so armor is always sorted alphabetically. So when a superhero comes in and asks for an armor, the clerk hands them whatever is alphabetically the first. Okay. And so Michelangelo goes to California, immediately gets arrested by local law enforcement. We don't do that here. Exactly. That's California on a lot of things. So armor. So if I show you guys, let's say C100, add armor B200, add armor D500, add armor A100. You can see that these things are sorted alphabetically at all times. Okay. So the reason why I'm doing this is not because it necessarily makes sense for items. Well, I mean, I guess it kind of does. If you're storing things in stock, then you know, like in a library, you can put them alphabetically. And the conceit here is that, you know, superheroes are in the middle of a fight, and so they just come in and they're like, I need a horse, and, you know, Thor reference. So you know, the shopkeeper just hands it whatever's first, you know, in the weapons aisle or the armor aisle or the gadgets aisle. Okay. And of course, the gadgets aisle, and you can add, you can have a weapons list and an armors list and a gadgets list all going on at the same time. So gadget would be like a bat belt or whatever it's called. The bat belt. What's Batman's belt called? Utility belt. The bat belt, which costs $10,000 because he's very rich. And then a gadget, a flash bomb, which costs $10, and a grappling hook, which costs $100. You'll see that gadgets are all sorted by price, and of course they're sorted highest price to lowest price. So when a superhero comes in, the stock clerk will hand them the most expensive gadget first. And so if I were to purchase a gadget, that would purchase the bat belt for $10,000. If I add another gadget to stock, let's say, I don't know, night vision, which costs $500, then you can see that the night vision is the new most expensive item. And if I were to add a new gadget, goggles, which cost $20. Do you see how that's always sorted numerically, highest price to lowest price? And then if we purchase a gadget, the night vision will be purchased because that was the highest thing. And so this assignment is going to teach you guys how to use the standard library. I've given you basically no starting code. This is different from other assignments where I would give you like the class and some like friend, OStream, and iStream operators. You can print them out and read them in. Write all that stuff yourself. The class is going to be very simple that you have to make for this. Every item is a name and a price. And that's true for weapons, armors, and gadgets. You don't need to make separate classes for them. I just use the same class for all of them because they're all just basically a name and a price. Okay. So so every time you add something to the list, you're going to push back the new item. And then for weapons, you're done. That's it. So when you add a weapon to stock, knife for $10, add a weapon, nunchuck, banned in California. You can see that weapons, they're just added, you just push back, push back, push back. It's just like a vector, except you guys are going to be using list. And the reason why we're using list is because when you buy weapons, they come off the front, see? And so you're doing push back and pop front. And so vectors would be very slow at that, right? If you were doing this with a vector, every time you deleted something off the front, that would be an order in operation. And for a list, it's order one. For a list, you push back and order one time, you pop front and order one time. So there you go. Okay. Okay, put stock into clearance. So we've got currently what, the knife and the nunchuck in the weapon stock. So let's put stock into clearance. So put what stock into clearance? Weapons. Okay. And so when you do that, all the items in the weapons list get tossed into the clearance aisle. And then you can put multiple stocks into clearance. Let's put armor in there. Oops. Put stock into clearance. Armor. And so now we've got these weapons in the clearance aisle. And then all of the armor in whatever order it was before. You just basically, well, you got all these armors on a rack. You just wheel the rack over to the clearance aisle. And so you can see the weapons that I put there were first, and then I added these guys to the clearance aisle. And I'm going to take the rack holding all the gadgets, like a clothes hanger with items hanging off it. I'm just going to wheel that over and put that after, put stock in clearance. So all the gadgets will go into clearance as well. And so now the clearance aisle has all of these things in it. And if I add a weapon, let's make a pistol for $300. you can see the weapons list has been cleared. So there's no weapons left in the weapons. There's no armors left in the armors. There's no gadgets left in the gadgets. They've all been moved into the clearance aisle. And so the prices don't change here. But when you purchase them, the first item on the clearance rack is the knife. And so you purchase it for half off. So this is list price still here. And so when you purchase it, you get it for half off when you buy it off the clearance aisle. And so basically you've got some stock, it's not moving, then you just take all your stock, push it over to the clearance aisle, 50% off. Okay? And so this can be done in order one time. This is something you cannot do with vectors. It is not something you do with maps. You can move an entire list to the end of another list in order one time. That's another benefit of using a list. We didn't talk about this last time, but yeah, you can't do that with basically any other basic data structure. So if I've got 100,000 weapons, I've got 100,000 armors, I've got 100,000 gadgets, I can move them all into the clearance aisle in 3 operations. Take all the weapons, put them in the clearance aisle. Take all the armor, put it at the end of the clearance aisle. So it's going to be all the weapons and all the armors. Take all the gadgets, put them at the end of the armors in the clearance aisle. 3 operations. So you can move all the items. You can move all the items from the weapons list into the clearance list in one operation. You cannot do this with vectors. You cannot do this with maps. You cannot do this with binary search trees. You cannot do this with, basically any of the other basic data structures, right? Okay. So, how do you do that? How do you move them? Well, there is a function called Splice, and I've listed Mart. So I've listed a bunch of functions that you will be using for this assignment. So Splice will it'll add one list to another list, and it does so in one operation. It's really nice. Okay. So Splice adds one list to another list. Okay. Push back will add things to the end of the list. Pop front will delete things off the front of the list. There's also list front returns the first item in a list. That's actually pretty useful. Pushback adds an item to the end of the list. Pop front deletes something from the front of the list. Splice adds all elements of one list to another. Sort sorts all the elements in a list. And clear erases all elements in a list. Okay. Clear is actually order n, but it's also order n for vectors. And the reason why it's order n is if you've got 1 million people in a list or 1 million people in a vector, it doesn't matter. You have to call the destructor on all of them. So some things are trivially destructible, in which case I think vectors might have a speed advantage there, where it just is like, these are all integers. They don't need to be destructed. And so it might be able to deallocate the memory in order one time. But I think technically the vector destructor is order n. Look at that internet speed. Look at that internet speed. There we go. C++.com. No. Can you just give me CPP reference? No, fine, whatever. We'll look at CPP.com. Complexity. Yeah. So when you destroy a vector, it has linear complexity. Are you guys starting to understand that vocab? Like people will just casually mention it's order n. It's order 1. So, like that vocab is just part of the way that computer science people talk. That's how we convey information. When I say splice is order 1, it doesn't mean it's exactly one operation, but it's constant running time. Okay, and so it's going to be far faster for a list. List order n. Because for a vector, you have to copy all the elements over. for a list, it does pointer tricks. Because every element of a list is just an integer or whatever, and then a pointer to the next node. And so if you have one list, the very bottom of the list is pointed at the null pointer, and then when you splice it, instead of pointing at the null pointer, the very bottom of the first list points at the head of the second list. That's it. That's all it has to do. It hooks them up like that. Now they're connected. They're spliced together. Done. Okay. So, what kind of code creates login? Yeah, binary trees. Anytime you're kind of dividing in half every time, that'll be a login operation. Okay, so pop front, push back. That's order 1. That would be order 1 for lists and vectors. Order 1 for lists and vectors as well. Pop front is order 1 for lists, order n for vectors. So that's another area where lists are going to be faster. Splice is also going to be faster. Sort is going to be order n log n for lists and vectors. Vectors are going to run faster though. Yeah. And then erase all elements is order n for lists and vectors. And again, vectors are probably going to be faster. Like when you actually benchmark it. So that's why we typically use vectors instead of lists. In general, they run faster. Even when the big O is theoretically the same, in practice, vectors tend to run faster. But for this assignment, since we're going to be doing a lot of splicing and we're going to be doing a lot of pop fronts, then that's why we're using lists for this instead of vectors. Because it hurts my brain to do an order n operation when you can do an order 1 instead. Okay. And you won't notice the difference when it's really small. When it's like 3 items, you're not going to notice the difference. But when it gets up to 1 million, 10 million, 50 million, then you will see the difference between, purchase a katana, and the thing freezes for like 5 seconds. And it's just freezing as it's just moving all the elements in the vector forward by 1. That's how the DMV people code their software. I was once at the DMV, and they're trying to look up my information, so I gave them my address, and they type it in, and they hit return, and I sit there for 5 minutes as it's trying to find me by my address, and I'm just sitting there like, this should be an instant lookup. There's only like, how many million people in California? This should be an instant lookup. Like, if it's taking you 5 minutes to find me by my address, you're probably going through every record of every person in California. One at a time. And comparing it against the string you passed in. I was just like, my computer science brain was just like utterly offended by that. Okay, so you cannot use vector for this assignment. The good news is list. If you know how to use vector, you know how to use list. Pushback is the same, front's the same, sort. Sort's different. You're going to call list.sort. Right. But basically, you're going to just make a couple data structures: one for weapons, one for armor, one for gadgets, one for clearance aisle. Make a class to hold items. An item should just be like a name and a price. Maybe write some operators, double left arrow, double right arrow operators. Make printing them and reading them in simple. It's not too bad, I don't think. Okay. And then the last thing is dump clearance items. So let's add some weapons, A and B and C, and some armor, A and A and B, A and some gadgets, A10 and B20 and C30. You can see how gadgets are always held numerical. So let's go ahead and dump. Let's purchase. Put stock into clearance. So let's put all the gadget stock into clearance. You can see C, B, and A have just been transferred from the gadgets aisle to the clearance aisle. Let's put stock into clearance. Let's put weapons into clearance. So you can see we've got all the gadgets. We got all the weapons. Names don't have to be unique. Prices don't have to be unique. We're not doing anything like that. And then let's put let's dump the clearance items. So dump the clearance items means throw them all away. Give them to charity. Give them to, superheroes who can't afford them. I don't know. And so if you dump the clearance items, then all of the clearance items are gone. And if we put stock into clearance, we still have the armors, right? So now the clearance items list is just the armors. So dump clearance items is clear. You're just going to call the clear function. So Mart. So this function here erases everything in a list. So if you have a list of items, named clearance, then this is going to do clearance.clear, right? That's it. So for the final option, you just call it clear on clearance like that, and it erases all of the items in the clearance rack. Okay, any questions about this homework? So this is pretty much a greenfield assignment. A greenfield assignment is one where you start from scratch. I was thinking about giving you some starter code, and I decided against it. I was like, nope. I want you guys to make a class. I want you to make operators on it. I want you to know how to sort, right? Sorting by name, sorting by price. So we talked about that last week. How do you sort by name? How do you sort by price? Well, you have to make a function, right? Bool sort by name that takes in two items, and then you return like I1.name is less than I2.name. And so that would, you'd have to make the item class. But assuming they have a name member variable, then this will, so when you call sort, like let's say you've got a list for armor, you'd say armor.sort, you pass in sort by name, like that. And then that will sort all the armors by name. Okay, so you have to make a function like this, or you can do a lambda if you want to be super cool. You just make a function like this, and then you pass that comparison function, or you can use the less than operator if you want. So that's how you sort things by name, and if you want to do it by price, it's the same thing, except you'd use price instead of name. That is your homework assignment. Let me push that back out to you guys. Hopefully none of you guys have done anything with it yet. CSF41, superhero, Mart, right. Okay, so it's got those updated comments that I left for you guys in it. Is this homework partnered? Nah, it's a pretty easy assignment. It'll be due next Monday. So, do we have next Monday off? Is it a holiday? Monday's a holiday? Okay, it'll be due next Wednesday then. Okay? And then your next homework assignment will be partnered. So for your next homework assignment, we're going to be doing a pretty cool project. Open-ended project, our first one. So we're kind of going back and forth between individual assignments and partnered assignments. Yeah, it'll be an RPG. Okay. RPG 41. Yep. RPG 76. What holiday? It's President's Day and Martin Luther King. So I think I don't know which is which. Okay. Get clone your map maker and share. Yeah. President's Day, Lincoln's birthday, Friday and Monday off. Yeah, something like that. Yeah. So, yep. Okay. So it'll be due next Wednesday, I guess. You guys got 9 days to do this. I actually created this whole thing between my class getting out at 11 and class starting at 12. So was about 45 minutes to do it, and then write up the README file. I was also answering students' questions on office hours at the same time. So it's really not that bad, but it'll give you good experience in working with a standard library and working with lists and things like that. I know what I'm doing, which is why it took half an hour or so to code, something like that. But literally each one of those options is 3 to 4 lines of code. So just start early. Don't. I know some of you guys got tripped up by FizzBuzz. FizzBuzz is also not a lot of code, but if you wait to the last minute, then you can be stuck, right? And that's the thing about computer science, is that people get stuck. And my best students ask questions, and they start. You don't have to start today. I mean, you can, but just start early enough that you have time that if you get stuck or if something's not working, you can ask me a question, and I can help you get unstuck. My best students usually are not the ones who are like smart or like whatever. Usually the best students are the ones that are good at asking questions. Like Muye here has probably asked more questions in 26 and 45 than any other student, and he's probably one of the top programmers at our school right now, right? He's probably TAing helps, but also just through the semesters he'll just send me a message on Discord or whatever, and I'll answer it, and he does really good. And I think there's probably a correlation there between asking questions and doing well in computer science. So don't wait till next Tuesday to start it. Just try doing what you can, and if there's something you don't understand, then ask me or post on the Help Center. All right, so yeah, Chris Johnson is here as well. You can ask him as well. Okay, so let's talk about linked lists. So how does a linked list work? We got half an hour left. Let's go over this. Then main.cc, rectangle bob. So let's make a linked list. And I'm going to do it pod style. Okay, so let's say I'm going to make a linked list of strings, integers, items. What do you guys want to make a linked list of? Containers can basically hold any data type you want. So sad I'm out of coffee. My wife's like, no. What do you guys want to hold? Numbers? Strings? Classes? Edrelin votes for classes. T's, we're not doing templates yet. If you don't ask questions, you're not learning. Yeah, it's really important. Anything works. Speaking of which, let's take attendance for today. All right. What should we hold? We're gonna hold a bunch of something. So data structure. Data structures hold a bunch of things. What do you want? What kind of things do you want to hold? Names. I'm here, bro. You gotta believe me. Did you get in before? I don't know. Let's find out. Edrelin. Is Edrelin in here? Yep. Okay. Strings. Okay. Linked list of linked lists. All right, sure. Let's do strings. So string name, or we'll call it data. And then a linked list will have a pointer to another linked list. That's what makes something a linked list. Okay? That's what makes something a linked list. And by default, we'll set our next pointer to be null. Okay, so null means there's nobody following me. So if I were to do this, linked list pointer head is equal to new linked list, passing in hello, or what do we want to do? This will be a wedding list. All right, linked list pointer wedding list, new linked list, and John Johnson. John Johnson's my old man, dude. Chris Johnson, and that's it. So if we do that, then next will default to null. Okay. And then let's do this. While true, cout, please enter a name to add to the wedding list. Just use my read library so it's not stupid. All right, so we'll read in a name, and then basically, let's see here. This enter temp current wedding list. So let me explain in just 1 second what this will do. So okay, so linked list pointer temp is equal to new linked list, putting in the name. All right, so let's say so all a linked list is it holds a single unit of data, and then it's got a pointer to another one of the same type. And so if you do this, then our wedding list will hold one name, Chris Johnson, and its next pointer will be set to null. And then I'm duplicating the pointer because this current thing is going to, as we add to the list, the current pointer is going to go down. The top of the list will still be the wedding list. And so we're going to have 2 pointers, one for the top, one for the bottom. This is a very common way of doing things. Head pointer, tail pointer. That's what they're called usually. And so class is not over yet. I have half an hour. 1:30, like I said. Coffee, please? No? No? Okay. All right. So, can't function. Okay, so, yeah. So we're going to create a new person to add to the wedding list, and we do so by newing it. So you might notice we're using new a lot, right? And so we'll need to do some deletes down here. Make a note of that. Marriage. Marriage is what brings us together today. A dream within a dream. Okay. So we've got Chris Johnson. Chris Johnson's next pointer is null. We've got this new person. We've just entered Connor McCohen, and Connor McCohen's next pointer is null, and so we need to hook them together. And so what we need to do is say current points to next is equal to 10. Add change. Okay, so the last person in the list now points at us, and then we're the new bottom of the list. So current is equal to 10. Move the current pointer to the bottom of the list, and then that's it. So if s is equal to done, break. Done to be done. Coffee, please. Thank you. Just take the current coffee, pour it in there. Not over the carpet. No, take the mug. No, take the mug. Here, take the mug. And then take the coffee, pour the coffee into the mug, and then bring the mug in. It's 3 steps. It's on the coffee table. That's why it's called the coffee table. It's got coffee. Okay. So, yeah, that's it. And then that will build a linked list. So I'm actually writing a linked list data structure from scratch. Pretty easy. So it's a Stein, yeah, 16-ounce Stein. Got 20-ounce Steins too. So yeah, this will build a linked list. So this creates a linked list here. Create a linked list. Build a linked list. And now let's print a linked list. And so for linked list pointer temp is equal to wedding list. As long as temp is not null, temp is equal to temp points to next. Cout temp points to name points to inline. So data. Okay, so there's a couple different things going on here, and it might be confusing to you. So let me just run it first and show you guys that it works, and convince me that it works because I haven't been able to get coffee. And then after I run it and you see that it works, then I'm going to go through this a line at a time, and I'm going to get out my sketch pad and actually sketch for you what is going on. So compile. Nope. Not in assembly. Not in assembly. No. It goes into the Stein. Into the Stein. There is no previous pointer in this one. There's no previous pointer. This is a singly linked list. This is the simplest possible implementation of a linked list. Okay, so let's compile it. Let's run it. Enter name to add to the wedding list. So let's add Moya, Edgerlin, Ephraim, Cohen, okay, and then it's going to print out the list of people that are invited by wedding. Chris Johnson, Moya, Edgerlin, Quiller, McCohen, and Buzikian. Okay. So that is a linked list. So let's go through this one line at a time. Coffee in a glass mug. Yeah. Because this is handled by people in DoorDash and stuff like that, so I don't like handling it because who knows, it could have coronavirus on it. So I always open it up, pour it into a mug, and then wash my hands afterwards. But my daughter, you know, it's pretty low risk anyway. So if I die, just blame it on her. All right. So what's going on here? So this creates a new, right? New always returns a pointer. So we've got here a function called new. New allocates enough memory to hold one linked list, which is a string and a next pointer. And this is the constructor for it. So if you don't have a constructor, that's fine. When you do something pod style, it'll actually generate a constructor for you. And the constructor simply copies the elements in order into the member variables. It's really nice. Like I said, I try to follow, I try to use the automatic generated functions when they're available. You know, there's no reason to waste time writing a constructor when I'm just doing a simple thing like this. So in reality, though, if I was making the list class, I'd have constructors and copy constructors and assignment operators and but for this, who cares? It's just class. So this code here is going to create a new node, a new linked list, and it's going to set the data to be Chris Johnson. And then the next pointer is going to be set to null. Null means there's nobody after me in the list. And so if I were to just print out this list as is and just type done, you'll see it just prints Chris Johnson and it finishes. Okay. The reason for that is because the next pointer after Chris is empty. It's null. Okay, make sure you have that. If you don't have that, then it might be null, might not be. Let's find out. Let's find out what will happen. Whew. This could be bad. Warning. Yeah, I know. It actually might null initialize it. It will do that for you. Yeah, but that is not a good thing. Always make sure pointers are initialized to null. Don't let, if this is uninitialized memory, because a pointer is just an int, right? On a 32-bit system, it's a 32-bit int. On a 64-bit system, it's a 64-bit int integer. Well, it's not an int, it's a 64-bit integer. And null pointer is 0. Okay? So null, you might see some people online just do this. That's fine. It's idiomatic. Every C++ programmer worth their salt knows exactly what this means. I don't write code that way. You could write just null like this. Null is 0, but at least you're indicating this is supposed to be a null pointer. Because when you write 0, like sometimes you might be like, do you mean the number 0 or do you mean memory address 0? You could do this, but it's better to write null. But null is just 0. And so if you screw up and make this an int or something, this will still compile. The best way of doing it is to say null pointer. Oops. So typing with one hand. Null pointer. Null pointer can only go into a pointer. Like if I screwed up and made this an int, it shouldn't compile. Okay. So maybe it'll compile. Let's see if it'll compile. Can't compile. Whereas if you did this with null, yeah, it's a warning, right? Because null, it's a warning because it knows that null is supposed to be used for pointers. And if you do this with 0, of course, everything's fine, right? So the reason why you use the null pointer to initialize something to 0 is because null pointer guarantees that the thing you're putting it into is a pointer. You really don't want to interoperate integers and pointers, even though behind the scenes a pointer is just an integer, really, or 64-bit integer on our system. You really don't want to use them interchangeably. Okay. Would the code compile with a blank constructor? It would. Yeah. This guy's got a default constructor, so data would be defaulted to 0, and then this defaults next to null. Null, 0, and null pointer are all the same, but you should use null pointer. Just there's no reason to use the other ones when initializing a pointer. Always use null pointer. Just rule of thumb, always use null pointer to initialize a pointer. Okay. Like I said, initializing it to 0 is idiomatic. Like you'll see that, but it's better. It's more typing. It's more typing, I know. But it's not that bad. Okay, so what's going on here? So this is going to allocate enough memory to hold a string and a pointer. A pointer is 64 bits. A string is depends. Depends. How much memory does the string take up? It's hard to tell. It's actually hard to tell. So at a minimum, it'll hold 5, 10, 12, 13 bytes for the string itself, but the string class has, I think, 3 pointers inside of it. So it's going to be, I don't know, somewhere around 200. I don't know. Doesn't really matter. So, anyhow, so it's going to create a pointer. So it's going to return a pointer to a block of memory that holds the string, and it holds the null pointer in it, the next pointer in it. Null is a pointer. Null is 0. So if you type capital NULL, that's actually just 0. But it's only supposed to be used in pointers, and so you saw the compiler warn if you try putting null into an integer, which you shouldn't do. Notice that Mr. Kearney one-hand typing is fast too. Yeah. Not as good, and I make a lot more mistakes doing it. Okay. Are struct and node class the same? A struct is the same as a class, except it defaults to public. So in situations like this, where I'm just putting something together really simply, I use a struct, and then when I do projects for realsies, I usually use classes, and I go through the rigmarole of creating get next and set next and get data and set data and all this kind of stuff. I haven't had enough coffee to do. Okay, so this code here is going to create a linked list. Okay, so this is the equivalent of the push back function, right? So in your supermarket code, you're going to be reading in a katana and pushing it back into a list. Reading katana and pushing it back into the list. This is what the standard library is doing for you. You don't have to write your own list for this assignment. For the next assignment, I guess the RPG, huh? Kind of want to have you guys do one more assignment before. It's a shame that there's a holiday next week. Well, I'll think about that a little more. Have them do Europa Universalis. Yeah, that's what I was thinking of. Have them implement it before doing the RPG. I'll have to think about that a little more. Maybe I can have this one be due on Wednesday. What do you guys think? Have it due in 2 days, and then we can squeeze another homework assignment in. What do you guys think? Kidding. You get 9 days to do half an hour of coding. It's not bad. All right. So what's going on here? So the first thing we do is we read a string, right? And if they type in done, quits out. You guys with me so far? You guys have any questions about these 2 lines of code? No, thank you. So, okay. All right. All right, fine. It won't be due on Wednesday. It'll be due next Wednesday. Okay, so do you guys understand what these 2 lines of code here are doing? So far, so good. Okay. So this is now going to make a new linked list. And so it's going to make a new one. Data is going to be set to S, whatever string they type in. If I type in David Thompson, then it creates a new linked list. David Thompson is the data. So at that point, we've got 2 linked list objects. One is Chris Johnson. Chris Johnson's next is set to null. We've got David Thompson. David Thompson's next is set to null. So we've got these 2 things. We need to connect them. And so the question is, do we want to connect David Thompson at the head of the list, so he's at the front of the line, or do we want to attach him at the bottom of the list, so he's at the end of the line, right? And so the question is, are we doing push back, or are we doing push front? And so the code's going to be a little bit different depending on which one we're doing, right? In this case, we're doing push back. And so this creates a new node, and then this is how you hook them up. So this is saying current. Current is currently pointing at Chris Johnson, right? So Chris Johnson's next pointer is going to be set to point to David Thompson. And so that hooks up Chris Johnson to David Thompson. So Chris Johnson's next is pointing at David Thompson. David Thompson's next is pointing at null. And I will whiteboard this out in just 1 second. And then current, which is the bottom of the list. So wedding list is the top of the list. Current is the bottom of the list. Sometimes these are called head pointers and tail pointers. I maybe should have called it that. I don't know. Whatever. So current then is pointing at David Thompson. And if you notice that when you use pointers, you use the arrow operator. So the arrow operator is the same thing as the dot operator, except it works with pointers. So don't confuse the two. If you have a regular object, use dot. If you have a pointer, you use the arrow operator. Same thing, but in Java, there's only dot. In C++, there is the arrow operator for pointer types, and there is the dot operator for regular objects, and you can't use them the wrong way. It just won't compile. But that basically means current dot next equals temp. If you were writing this in Java, that would be current dot next equals temp. Yeah. Okay, and so then current equals temp, and so the pointer to the bottom of the list moves down. It's now pointing at David Thompson. It then goes to the top of the list. If we type in Wyatt Bender is not equal to done. So we create a third node, and the data is set to Wyatt Bender, and Wyatt Bender's next is set to null pointer. So we've got 3 nodes, Chris Johnson, who's pointing at David Thompson. David Thompson's next is pointing at nobody, and Wyatt Bender is pointing at nobody. Then David Thompson's next now points at Wyatt Bender, and the bottom of the list is now Wyatt Bender. And so in such a way, it keeps adding things to the bottom of the list over and over again until we type done, in which case we then print the linked list out. Okay, and this is how you print out a linked list. This pattern here is very common to iterate across an entire linked list. And so what this says is create a pointer to the top of the linked list, creates a pointer to the top of the linked list, and if the pointer ever becomes null, quit the linked list. Remember, null is 0, 0 is false, and so if the pointer ever points at null pointer, this guy, 0, then the loop ends. Okay. So this starts off by pointing at the top of the list, Chris Johnson. Is the pointer null? Nope. So then it will print out temp points to data, which is Chris Johnson, and then it says temp equals temp points to next. This is how you move to the next item in a linked list. Temp equals temp points to next. So we were pointing at Chris Johnson. Yeah, Chris Johnson's next pointer is Dave Thompson. So then temp is now pointing at David Thompson. Is that pointer null? Nope. So it prints out Dave Thompson. It then says temp equals temp points to next. It's now pointing at Wyatt Bender. Is that pointer null? Nope. So it prints out Wyatt Bender. Temp equals temp points to next. It's now null. Null is false. It terminates the loop. And this will print out the whole thing. So let me go pause the stream while I wash my hands. My daughter gave me, who knows, potentially contaminated mocha. I'll be right back, and then I'll whiteboard. All right, and we are back. Let me pull up OneNote and just sketch this out for you guys. 41, page 2821. Okay. Everything started making sense once arrow syntax was explained. Yeah. So we typically draw linked lists kind of like this, with the data up top and the pointer down below. So when we started off with our linked list, we had a wedding list, and that's a pointer, and it points at this node here. And it starts off with Chris as the data, and its next is null. Okay. And current was also pointing at this. So we had 2 different people pointing at the same node, 2 different pointers pointing at the same node. Remember, a pointer is just an integer, right? And so when you call new returns this memory address right here. It returns the start of that block of data, however big it is, right? And so the wedding list variable just holds that memory address, and then current holds that memory address. And then when we create our second one, we create Thompson, just put in the first name, David. Its next is initialized to null as well. And then we set Chris's next to point to David. And then we set current to point to David as well. And then we create the third one, Wyatt. Its next is set to null. His next is set to point to here, and current is set to point to here. And so that's what's happening in code. And whenever you work with linked lists, it's really important that you kind of sketch them out to begin with, because everything that you do, like change it, like, you know, like current was pointing at David before, and then we change it to point at Wyatt instead. Anytime you kind of put ink to paper, you know, and change something like that, there's going to be a line of code for that, right? And so that would be this line here, current equals temp, right? So temp is the new person that was just allocated. Current points to next equals temp. That is when we link this up here. So before this guy was null. And then after we say current points to next equals temp, current was pointing here, temp is pointing here. When we say current points to next equals temp, then what happens is this changes to be this. And then we say current equals temp, and so then that changes. And then if we were to do it one more time and add a new person to it, then we would allocate a new block of memory. Let's say Muya gets invited to the wedding. Muya, Wyatt point here. Muya's next would be null, and current would point to Muya. So this is this is how linked lists work. There's variations of linked lists. There's doubly linked lists where every person has a pointer to the person after it and the person before it. It's pretty common. There's circular linked lists where the last person points to the first person. But this is enough to kind of get you guys going conceptually. So pointers are just integers. They just hold memory addresses, and you can just assign one pointer to another pointer. It doesn't copy anything. It just, so like if temp is pointing, like when we call new, like when we newed this memory here, new returns a memory address. It returns just this memory address right here. And so we save that memory address into temp like this, right? So new allocates a block of memory and just returns the integer that that block of memory starts at. And so we're just saving that integer into this guy. And then the current bottom of the list, his next is going to be set to that integer. That's the next memory address. Then we set the bottom of the list to be that memory address. So so temp gets set to be there, and then current points at it, and then when we knew something else, temp points here, then current, current points to next points at it, and then current points at it. It looks a lot more complicated than it actually is. You can actually write code to work with and create linked lists pretty simply. The trouble is just if you do something wrong, you'll segfault, right? Like a lot of students will screw up, and I don't know, they end up getting these weird pointer chains and things like that, and it happens. But their code will run forever, or it'll segfault or something, and it can be hard to diagnose the problems. So we'll work with bridges, and bridges will allow you to visualize a linked list. So fsanitize equals address will detect when you double delete, or if you go off the edge of memory or something like that. Last and init fits where in the code? Last and init. What is last and init? Terminology? I don't follow. This is oftentimes called head. This is oftentimes called tail, or this could be first. This could be last, if you like. This is the top of the list. This is the bottom of the list. Head, tail. So as we add things to the list, the tail keeps moving down to the bottom. The head stays where it is. So this variable called wedding list, a lot of people would just call this head. And then current we would call tail. Same thing. Pseudocode in Zybox explicitly assigns head and tail to pointers. Yeah, it's just, I'm just calling it wedding list instead of head. It's the same thing. Does the tail always point to null in the end? Yes. That's how you know you've got the end of the list. If you don't, and you're like you're doing this list here, this print thing here, that's how it knows when to stop. It's when the temp pointer moves to the next and it becomes null, then that highlighted word right there is false. Null pointer is the same thing as false, and so it will terminate the loop. And so null pointer is 0, 0 is false. So this is a very concise, very compact way of just iterating through a linked list, printing all the elements, and then terminating once temp runs off the edge of the list. How do you sort a list? For your homework assignment, you're going to call list.sort. Okay, so you're gonna call the sort function on the list class in the standard library. Okay. It's not you don't have to write your own sort function. Pseudocode in Zybox explicitly assigns head and tail with the pointers. So yeah, I mean, it's, if I wanted, I could do this, right? That's fine. I don't need to. Right? I don't need to do that because I've got a default constructor in there that will set it to null pointer for me. So I don't have to explicitly type it every time. Okay. Good news is you don't have to write a linked list for the current assignment. You're going to have to write one eventually. But for this current assignment, all you have to do is use the standard libraries implementation of linked list class to get comfortable with using linked lists, and then you will eventually have to write one. So this usually causes people's brains to explode at least a little bit. So if you're feeling a little bit like there's smoke coming out of your ears, that's normal. The good news is it's kind of like, it's one of those things where, like, after you understand it, you're like, ah, it's really not that bad. But you just blank most of the time. That's why we make you code, because if you do it, then you understand it. Yep. So that was just you fuming after looking at the code. Yeah, it's not a lot of code, right? It's not a lot of code. It's just that makes a new linked list. That hooks up the new linked list. See, that's the new guy. So the old tail. Here, I'll even change it so the terminology matches. Zybox. Okay. So go. Only a few lines of code. Make a new node in the linked list. The next of the current tail is the new guy, and now the tail is the new guy. So that hooks up the new guy to the bottom of the old list, and then the bottom of the old list is now the new guy. You just keep doing that until the user type's done. And then to print it, we make a copy of the head pointer. And then we just go down the list, printing all the elements until we hit null. Does std list allow you to manually adjust pointers? No. The std list will hide the internal implementation from you. That's the whole point of an ADT, is that the implementation and the interface are separate. So if you want to add one list to another list, they provide an interface for that called Splice that will do the internal pointer magic, so that it does something like this. When you call Splice, it basically sets the bottom of the current list, it sets its next to be the head of the old list. One operation. And then that's it, because the bottom of the old list has a null on its tail as it is, so that's all it has to do. One operation. So rather than having to copy over a million things from one list to another, you can splice them together. And then if you did that with a vector, it would take 1,000,000 operations. With a list, it's 1. Yeah, so std list does not give... It doesn't have what's called intrusive pointers. You just have to go through the interface of like append and I don't know, accumulate, sort. You basically use the interface they give you, and that actually loses you a little bit of flexibility. Like, it's actually very useful sometimes to be able to get access to the internal pointers, so you can do all sorts of clever tricks with it and stuff. In general, though, you can get iterators. Iterators are basically pointers, and so you can have a pointer like the middle of a list and kind of do tricks with it, but it does actually hide the implementation behind a wall of ignorance. You'd still peek stuff and do something with it if you wanted, yeah, but then you're veering into undefined territory, undefined behavior territory. Like nothing that's private is actually private. It's just there to keep you from shooting yourself in the foot. If you want, you could grab the pointers inside of the std list and play with them if you wanted, and you'll probably break something, right? So it's better to not. There's for your homework assignment, there's no need for any of that. All the std list class gives you everything you need for the homework assignment. Okay. Which library is read defined? It is not part of any library. It is my thing. So it's in /public/read, and it allows you to do input a lot better than how C++ does it normally. So the equivalent for this in C++, standard C++, is string s semicolon cn cout, please enter a name, blah 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 blah, cn into s, right? So these 3 lines right there are the same as that 1 line right there. And if you do an error or something like that, then you've got to be like, if not cn, cn dot clear the error, and then you have to put all that thing into a while loop so you can reprompt, and it's a giant mess. Like, honestly, the read libraries is just a better way of doing input, because you can make this a constant if you want. You can't do that in standard C++. And if you want to be really cool, you could do something like this. You'd be like vector.push back read and so you can actually layer the read inside of a pushback call, and actually just because it's a function, and so when things are functions, you can actually encapsulate them inside of other functions and things like that. And if I wanted, I could put an abs around that, and so there's just like 7 different reasons why you should be using the read library instead of standard C++. The only reason to use standard C++ is if you want to take your code elsewhere. What does the algorithms library do? I'm always curious. I think we went over that last week. It has sort and accumulate and shuffle and things like that in it. Okay. Yeah, so link. This is all the code it takes to make a linked list. There we go. You got a head and a tail. There's the entire class. A couple pointers to the top of the list, bottom of the list. That adds something to the bottom of the list. That prints it out. It's only this much code. And it will still hurt your brains for a while until you kind of wrap your mind around it. Okay. So that's it for today, guys. Thanks a lot. And we'll pick up more discussion of linked lists on Wednesday. Don't worry about needing to know how to write it for now. For the homework assignment, you're just going to be using it. You're not going to be writing. And if you have any questions, let me know. It'll be due next Wednesday. All right, peace out.